everyone. Let's see this question. So in this question, the electrostatic force on a small sphere of charge. So charge is given as 0.4 microcoulomb. Due to another small charge, another charge is given as negative of 0.8 microcoulomb in air, and the electrostatic force is given as 0.2. Now how this is the electrostatic force we know. So from unit, Newton is the unit of force, so 0.2 Newton is the value of electrostatic force. Now in first part we need to find the distance between these two spheres, and for B part we need to find the force on the second sphere due to first. Now let's understand this more with the help of figure. So suppose this is the small charge of, let's say, this charge Q1, and that is given as 0.4 microcoulomb, and another charge is given, let's say this is Q2, charge of value minus 0.8 microcoulomb. Now as this is given as positive value and this charge is negative, so we know that the opposite charges attract each other. So opposite charges, positive charge and negative charges are attract each other. Now also we have given this force value. The force of attraction between these two charges is given as 0.2 Newton, and we need to find this distance that is denoted as R. So we need to find this R value. Also in B part, we need to find the force on the second sphere due to first. So we can write force due to second sphere due to first sphere. So we need to find this force also. Now let's write what we have given in this question. First we have given the charge on first sphere, that is denoted as Q1, and the value given is 0.4 microcoulomb. Now as we know, 1 microcoulomb is equal to 10 to the power 6 coulomb, because coulomb is the SI unit, so we need to convert this microcoulomb into coulomb. So just we need to write 0.4 into 10 to the power 6 coulomb. Also we have given charge on second sphere, that is denoted as Q2, and the value is minus 0.8 microcoulomb. Again we need to convert this into coulomb, so minus 0.8 into 10 to the power 6 coulomb. Also we have given electrostatic force. So the force between the charges is denoted as electrostatic force. So electrostatic force on first sphere is given as, so force F is given as 0.2 Newton. Now using the formula for electrostatic force, so electrostatic force is denoted as F, and that is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Now epsilon naught is the permittivity of free space, as we have given the air, that is medium given. So epsilon naught is the permittivity of free space, and as we know the value of this constant term, also denoted by K, that is equal to 1 upon 4 pi epsilon naught, and the value is 9 into 10 to the power 9 Newton meter square per coulomb square. Now for first part, we need to find the distance between the sphere, that is R. So we need to rearrange this formula for R. So R square will be equal to 1 upon 4 pi epsilon naught Q1 Q2 upon F. Now substituting the values here. So in this 1 upon 4 pi epsilon naught is 9 into 10 to the power 9 into Q1 is given as 0.4 into 10 to the power minus 6 into Q2 is minus 0.8 into 10 to the power minus 6 divided by F. F is given 0.4. Now to solve this value, we need to separate numerical terms and power terms. So numerical term is 9 into 0.4 into minus 0.8. So we need to solve this as a whole. Into power term is, as we know, multiply, then we need to add the powers. So 10 to the power 9 minus 6 divided by 0.2. Now when we solve this, so point will be cancelled out with point, and when we cancelled out this point, then we need to add this 0 term in denominator. Now we have 9 into 4 into 8 divided by 2. So when we solve this, 2 4s are 8. So 4 4s are 16 into 9. So that is 144. So here we get 144 into, so for numerator 9 minus 6 minus 6. Now here we have term 1, 10 to the power 1. That is when it's converted to numerator, that sign change. So we get minus 1. Now to solve 9 minus 6 minus 6 minus 1. So 9 minus minus plus, that is minus 12 minus 1. So 9 minus minus again plus, so minus 13. So 9 minus 13 is minus 4. So we get 144 into 10 to the power minus 4. Now in left hand side we have a square term. So when we remove a square term, we need to square root 144 into 10 to the power minus 4. Now the square root of 144 is, we can calculate this as 144. We need to square root 2 7s are 2s are 2. We need to factor this 3 36 2 18 times 36 2 9 times 18 3 3 times 9 and 3 1. So we have pairs, that is 3 2 2. So 3 2 2. 3 2s are 6, 2s are 12. So square root of 144 is 12 into square root of 10 to the power minus 4. 4 is the square of 2. So we can write 10 to the power minus 2. So this is the value of distance r. So the distance unit is in meters. Or we can write this distance r will be equal to 12 into 1 upon 10 to the power minus 2 can be written as 1 upon 100. So 12 upon 100 can be written as 0.12 meters. Therefore, the distance between the charged sphere is 0.12 meter. Now for part B, due to the first. So for part B, as the sphere have opposite charges, that is positive and negative, so they have opposite charges. So both the sphere attracts each other with the same amount of force, because as they have opposite charges, so they applied each other at the same amount of force. So we can say that the force on the second sphere due to the first sphere will also be equal to the same that we have find, that is 0.12 Newton. So this is the required solution. If you find this video useful, do like and subscribe. Thank you.